Okay, these notes are over graphing linear systems of equations. So, a system of equations is a set of two or more equations containing two or more variables. There is possibilities that you can have three variables and three equations, four variables and four equations, but for our purposes today, we're going to have two variables with two equations. A linear system contains only linear equations, which makes sense since the name is called linear systems. And a solution of a system is the set of points where the lines intersect. So what we're going to be doing today is we're going to be graphing two equations and seeing where they intersect. And if they do intersect, then the point where they intersect is our solution. And then the point is a solution to a system if the x and y value satisfy both equations. So there's three different scenarios that can happen with linear systems. You can have exactly one solution, which means that the two lines, when you graph them, cross each other at one specific point. And that point would be your solution. So this one looks like it would be at 2, 5. So 2, 5 would be our solution. There's also a situation where when you graph your two linear equations, they are actually the exact same line. And when that happens, we have an infinite number of solutions. So any point along this line is a solution. So there's an infinite number of solutions. And then there's also the scenario where there's no solutions. And that happens when you have two parallel lines. And the reason why there's no solution when you're dealing with parallel lines is because parallel lines never cross. So there's nowhere that the lines are crossing to be a solution. So solving the system by graphing, I have the system 2x plus y equals 13 and x minus y equals 5. And this is all worked out, but I'm going to talk through what actually happened. So for 2x plus y equals 13, we have to get it in y equals form to be able to graph it. So you subtract 2x. So that's how we ended up with the equation y equals negative 2x plus 13. And then for x minus y equals 5, you subtract x from each side. And then you divide everything by negative 1. So that's how we ended up with the equation y equals x minus 5. So first you need to graph y equals negative 2x plus 13. And the way that we graph that is we started our y-intercept of 13, which is way off the graph, somewhere probably about right up there. So we'll start with our y-intercept. And then from there, you go down to right 1, down to right 1, down to right 1. And then connect your dots. So this line right here is negative 2x plus 13. Then to graph y equals x minus 5, you start at negative 5. And then your slope is 1 over 1, so you go up and over 1 every single time. So this second line right here is y equals x minus 5. So these two lines intersect at this point right here. And that intersection is the point 6, 1. So we have one solution, and that solution is 6, 1. Also, we write all points in parentheses with your x, comma, then your y. So if it's not written as a point, you're not going to get full credit for it for our purposes. Okay, another example. I have 2x plus 3y equals 6 and x equals negative 3. So we have to get the first equation y equals form. So we subtract 2x. So you would have 3y equals negative 2x plus 6. And then divide everything by 3, which a lot of people forget to divide both the negative 2 and the 6 by 3. So that's how we end up with the equation y equals negative 2/3 x plus 2. And then we don't have to do anything to our second equation of y equals negative 3. So to be able to graph y equals negative 2/3 x plus 2, you start at your y-intercept, which is positive 2. And you go down 2 and to the right 3, down to right 3. We can also go up to left 3, up to left 3. And then to graph x equals negative 3, It's just this vertical line right here going through where x is negative 3. So these 2 points intersect right here at negative 3, 4. So we have one solution, and that solution is negative 3, 4. Okay, so that's basically all we're doing with the graphing. We're graphing the 2 lines. Where they intersect is our solution. If they don't intersect, it's because they are parallel lines, so they would be no solution, or there's the possibility that they're the exact same line, which would be an infinite number of solutions. Now, if you are asked whether a point is a solution for the system, the way that you can check it is by plugging that point in, and the left side of your equation should equal the right side. So I'm asking right now, is 2, 4 a solution to the system x minus 2y equals negative 6 and 2x plus y equals 8? So how we can test that is we're going to plug in 2 for x and 4 for y and see what happens. So I'm going to do 2 minus 2 times 4 equals negative 6, which is 2 minus 2 times 4 is 8 equals negative 6. And 2 minus 8 is negative 6. So I get that negative 6 equals negative 6, which is true. All right, now we have to do this process again, plugging in 2, 4 into the second equation now. So I'm going to do 2 times 2 plus 4 equals 8. 2 times 2 is 4, and then we have plus 4 equals 8. And 4 plus 4 is 8, so I get that 8 equals 8. Which is true as well. So 2, 4 is a solution to that system. All right, our next example of this is 3, 2, a solution to the system 2x plus 3y equals 12 and 8x minus 6y equals 24. So I'm going to plug in 3 for x and 2 for y and see what happens. So 2 times 3 plus 3 times 2 equals 12. So 2 times 3 is 6, plus 3 times 2 is 6, equals 12. And I get that 12 equals 12, which is true. You cannot stop there, though. You have to plug 3, 2 into both equations. So I now have to do the second equation. So 8 times 3 minus 6 times 2 equals 24. So 8 times 3 is 24, minus 6 times 2 is 12, equals 24. And 24 minus 12 is 12. So does 12 equal 24? No, that does not work. So 3, 2 is not a solution to this system. So you can use that way to check yourself when you're graphing. After you finish graphing, you can plug your solution into your 2 equations and make sure they make sense. Also, tomorrow we'll be working with solving systems by substitution and then by elimination. So this is an excellent way to make sure that you've done this correctly, is to plug them in and make sure that the left side of your equation equals the right side. And that is it for graphing linear systems.